Hello everyone, you're welcome once again to another math class. Today in our lesson we'll be looking at equivalent fractions. Actually we started this topic on fraction last week. We're able to look at what fractions are, types of fractions, the names, and then we're able to also look at the addition and subtraction of like fractions. Okay, those are what we were able to cover for last week. So this week we are still continuing our study on fraction. Remember I mentioned last time that fraction is quite a vast topic. It's a wide topic, so we're just going to take our time and explore the different aspects of fraction. So today, one of the areas we'll be looking into, one of the aspects of fraction we'll be looking at is equivalent fractions. Equivalent fractions. What do we mean? What is equivalent fractions? When we say equivalent fractions, they simply refer to the different fractions, it could be two or more, that represent the same amount or the same value. Equivalent fractions are fractions that represent the same amount of value, but they have different numbers. They are expressed with different numbers, but their value or amount are the same. Okay, so we're going to use this model here on the board, this drawing, to try and explain what equivalent fractions are. So if we look at these two circles, they are the same and actually intended to be, regardless of what they look like. Maybe one may look a little bit smaller or bigger than the other. Okay, these are exactly the same size, the two of them. Okay, but when you look closely, you will find out that one of them, this first one, is shared into 6 equal parts. Okay? Now that reminds me, let me quickly say this before we continue. Whenever we're talking of fractions and parts, please note that it's very important for the parts to be shared into equal parts. They have to be equal. If one part is small and the other side big and all of that, you cannot say you cannot use that to represent that whole quantity, as fractions. You can't use those sharings that are not equal. Whenever we're talking of fractions, whatever amount it is shared into, the whole is shared into, it has to be on equal terms. They have to be equal in amount or size. So like if you look at this first circle, it is shared into 6 equal parts. 6 equal parts. This is one of the parts. This is second one right here in the middle, and this is third one. Okay, so this 1, 2, 3, 4, 5, 6. Okay, those are 6 equal parts. Let me just write 1, 2, 3, 4, 5, and 6. Right? Now let's go to the second diagram, the second circle. If we look at this circle, it's exactly the same size as the first one. But if you look at it closely, you will find out that this second one is shared into just 4 parts. It's shared into 4 equal parts. Okay? So this is it. 1, 2, 3, 4. Now I want you to look at these two diagrams. Assuming this is, I always love to use pizza, forgive me. Okay, I know a lot of kids love pizza. Now just assume that this is a pizza that has been made, 2 actually. Okay, the same size of pan, and they come out the same way. Then one is shared into 6 equal parts, while the other is shared into 4 parts. Now I want you to take a look at the diagrams and try to observe the shaded parts of the two circles, or let's assume that the shaded parts of the circles are actually pizzas that are given out. Okay? Now let's assume that this first part is given to John, okay, while the second part is given to James. Now look, just use your eyes and look at them. What do you think about the size, the actual size? Forget about the numbers now, because John actually is getting 3 pieces, while James is getting just 2 pieces, right? James is getting 2 pieces, John is getting 3 pieces. But you just look at the two circles. What do you think about the actual amount of pizza that each of them gets? What do you think? Do you think John got bigger pizza than James because he got 1, 2, 3 pieces? Or do you think James got less amount of pizza or smaller size of pizza than John because he got just 2 pieces of pizza? If you look at them closely, you will see that the shaded parts in the two circles represent the same amount. Because like I mentioned earlier, this is the size of the pizza, exactly the same size. The 2 pizzas, the whole, when I mean the pizza, I'm referring to the whole now. They have the same size. The same size of pan was used to bake them. They came out exactly the same size. Okay, now we are talking of the sharing. So looking at the amount that James got and the amount of pizza that John got, do you think one got more pizza than the other or less than the other? No. They both got equal amounts of pizza, though different pieces. They got different number rather of the pieces of pizza. John got 3 pieces, 1, 2, 3 pieces of pizza, while James got 2 pieces, 1, 2. But if you look at the size overall, they both got the same size of pizza, the same amount of pizza. Why? If you look at these parts here, these are 3 parts, but each part is smaller than the one part here. Remember, this is shared into 2 parts. One of these parts is smaller than one of these parts. So at the end of the day, when these 3 parts combine, they give you exactly what these 2 will also give you when combined. Now, looking at the picture alone, you will see that these are exactly, the 2 are the same size. So what are we trying to bring out? That the 3 parts of this pizza, which is 3 out of 6, okay, is the same as the 2 parts of this pizza. It gives the same amount, it gives the same size, which is 2, 1, 2, 3, 4 out of 4. So in other words, let me make it clearer. In other words, you say the 3 out of 6 and these 2 out of 4, they are equivalent fractions. 3 out of 6 and 2 out of 4, they are equivalent fractions. That means both of them have equal value. That's the word equivalent actually from equal. It's equal. That's what it means, equivalent. Okay, that means the 2 fractions have the same amount, or they represent the same amount or the same value. So if you look at the side, just merely looking, you'll find out that they are the same size, though this one is 3 parts while this one is 2 parts. But by the time you join them together, join these 3 parts together, join these 2 parts together, what you're going to get for each of them is the same. Okay, the overall is the same as what you have on the other side. So you say that 3/6 is what we call, remember in our last lesson we looked at the names of fractions. Okay, so this is 3/6 and this is 2/4. So we find out that 3/6 is equivalent to 4th. They are equivalent fractions. 3/6 and 2/4 are equivalent fractions. All right, so here is another example we're going to look at. Okay, another example of equivalent fractions. So if we look at these two rectangles, the first one here is shared into 4 equal parts. First of all, for a start, it's important to note that the two rectangles are exactly of the same size. Okay, these two rectangles are the same size. Now, the first one is shared into 4 equal parts. It's shared into 4 equal parts, while the second one is shared into 8 equal parts. Just trying to make the lines visible. So here you have 1, 2, 3, and 4. Okay, while this one is 1, 2, 3, 4, 5, 6, 7, 8. Remember, both of them are equal size. Okay, they have the same size. One is shared into 4 parts, while the other is shared into 8 parts. Now, for the first one, the first rectangle that is shared into 4 parts, one part is shaded, while the one that is shared into 8 parts has 8 parts out of the, has 2 parts out of the 8 shaded. Okay, now just take a look, just a visual assessment of the two rectangles. You would notice that the shaded portion here looks exactly as the same size as the one with the 2 portions shaded. Just taking a visual assessment, you will see they look the same size. And they look the same, as if they're the same size, because they're actually the same size. Why? They are the same size because the parts, everything for this one is the same as everything for this. And now if you look at it, this is shared into 4 equal parts, while this is shared into 8 equal parts. Now you know that 4 is half of 8, or 8 is 2 times of 4. So that means if one part of 4 is shaded, then it's 2 parts of 8 that will be shaded together, 1 part of 4. So this 1 part shaded here in this rectangle is the same as the 2 parts shaded in this second rectangle. It's exactly the same size. That means that 1 out of 4 is equivalent to, this is 2. Okay, let me write them in the middle. So this 1 out of 4 is equivalent to 2 out of 8. Okay? So, assuming these bars, let's just assume that this is like a chocolate bar, big chocolate bar. You know, there are those chocolate that you have demarcations in the middle, but you have to break it eventually, okay, to take the part you want. Now, let's assume this is a chocolate bar, this is another one, okay? And this is shared into 8 equal parts, but they both have the same size. Now, if one child is given this first part, where the chocolate is shared into 4 equal halves, if you give a child one of this one shared into 8 parts, the child here is definitely getting a smaller amount. But when you give 2, you find out that the 2 of them have exactly the same amount of chocolate. They have exactly the same amount. Just looking at it, taking a visual look, just looking with your eyes, you will see that the size of this shaded portion is the same as the size of the shaded portion, even though they have different numbers. This one is just 1 part shaded out of 4, while this is 2 parts shaded out of 8. So 1 over 4 and 2 over 8, they are different numbers, but what do they represent? They represent the same amount and the same value. So this is another example of equivalent fractions. I hope you remember the terms we used last time for these numbers that represent fractions. Remember, we said the upper one is the numerator, and we refer to it as the baby. And when we get to certain aspects of this exploration, you will understand why. And then the one below is the denominator. The upper one is the numerator, and the one below is the denominator. Okay, we're going to take a look at how we can come up with equivalent fractions. Creating equivalent fractions for any fraction is quite easy. It's very easy, to create equivalent fractions for a certain fraction. So to create equivalent fractions for any fraction at all, what you simply do is to multiply or divide both the numerator and the denominator by the same number. If you want to get the equivalent fractions of any fraction, what you simply do is use a particular number to multiply both the numerator and the denominator of the fraction, or use a particular number to divide both the numerator and the denominator of the fraction. The answer you get is definitely an equivalent fraction of the original fraction. Okay, so here is an example. We have the fraction half here, 1/2. So this is a fraction. Now we want to create an equivalent fraction of this, just one for a start. So what do? You write your 1/2 or half, and then you multiply it by 2/2. What are we doing? We are using these two to multiply numerator, and we're also using the same two to multiply the denominator. We can choose 3/3, provided it's the same number you are using to multiply the numerator and the denominator. The answer you will get will definitely be an equivalent fraction of this original fraction. Okay, so this is just what we did here. We used 2/2 and we got 2/4. So that means 2/4 is the equivalent fraction of 1/2. Is an equivalent fraction, not the. I can't use the because it's not the only equivalent fraction. So 2/4 is an equivalent fraction of 1/2. Now I drew this circle here to create a visual effect again, to check with the answer we got. Okay, remember we're dealing on equivalent fractions. We say they have different numbers, but they represent the same value or the same amount. Now, if you look at this, there are two circles, the same shape, the same size. Okay, but the first one is shared into two parts. Okay, and part of it is shaded. The second one is shared into 4 equal parts, and 2 parts are shaded. Even though 1 part is shaded here and 2 parts are shaded here, if you look at them visually, you can tell that they have the same value, they are the same amount. The parts that are shaded have equal amount, or they look the same. Okay, that's just what we're trying to prove here, that 1/2 has the same value as 2/4. Okay, now I'm going to show you other numbers that you can generate that are equivalent of half. It's not only 2/4. So I've just used this part, only this number for now, so that I can use this to prove to us why we say that 1/2 is the equivalent of 2/4. We're going to look at more examples now. All right, so here we have other equivalent fractions of half, or 1/2. And this is simply how you generate equivalent fractions. Or this is one way, because another way you can also generate equivalent fractions is by dividing a certain fraction with the same number, dividing the numerator and the denominator by with the same number. You can also generate equivalent fractions. We're going to look at that shortly, but first, let's look at this. Remember the first example we showed just now, we showed you 1/2 times 2/2, it gave us 2/4. And then we use a model, something that we can use our eyes to assess and see if it confirms what we are trying to do here. Okay, now we're just going to go ahead and use that law. Remember, we just we stated a rule that tells us how we generate equivalent fractions, and that is, you simply multiply the numerator and the denominator of the fraction with the same number. The same way you can also divide the numerator and the denominator of the fraction with the same number to get equivalent fractions. So here, 1 over 2 times 2 over 2 gives us 2 over 4. That means 2 over 4 is an equivalent fraction of 1 over 2. Now let's move down. You have again 1 over 2 times 3 over 3. It gives us 3 out of 6. 3 over 6 again is an equivalent fraction of 1 over 2. 1 out of 2. Again, 1 over 2 times 4 over 4. Half times 4 over 4. 1 times 4 is 4. 2 times 4 is 8. So again, 4 out of 8 is equivalent. Is an equivalent of half. And lastly, you have half times 5 over 5 equals to 5 over 10. And that again shows that 5 over 10 is an equivalent of 1 over 2. So let's just take one of these to prove again that they actually have the same value as this half. We can pick any of them. Okay, maybe we pick 3 over 6 this time. Let's pick 3 over 6 to see if it's the same value, okay, as 1 out of 2. Let's use, what can we use? Let's use a square. I'm not sure if this is a square, but let's assume it's exactly the same size as this second one, okay? So the first one is shared into 6 parts. It's supposed to be, yeah, let's do this 6 parts since we've already taken, okay? That's 6 parts, right? And this is just shared into 2 parts. Okay, so this one says that 3 parts is the same. 3 parts out of these 6 parts, this is 3 out of 6 that we're going to shade, will be exactly the same as 1 part out of these 2 parts. Let's see. So we're taking out 3. So that's 3 parts that we've taken out. And here we're taking out just 1 part. Okay, so now let's just take a look. Looking at it, you can tell that the portion, the area of this one that is 3 parts, this shaded part, is exactly the same size as this area that is just 1 part shaded. It just goes to prove. The important thing is the 2 of them have to be, the whole have to be the same size. Okay, that's how you can get the real equivalent, even though the numbers may be different. Okay, because at the end of the day, we are looking at the whole picture together. So these 3 shaded parts is exactly the same size as this one shaded part. So that proves that 3 out of 6 is the equivalent of 1 out of 2. You can try it with others. You still arrive at the same thing. These are equivalents. Now we are going to do a reversal. Okay, remember we said that you can either multiply the fraction by the same number to get the equivalence, or you can divide the fraction by the same number to get the equivalent. So let's look at how we can use division to get our equivalent fractions. All right, let's look at the fractions we have on the board. We're just trying to see how we can use division to also get equivalent fractions of a certain fraction. So the first one we have here is 2 over 4, that is 2/4. Let's see how we can get the equivalent of it using division method. Now 2 out of 4. If we look at this using the rule of divisibility, one of the rules, We know that 2 is an even number, 4 is an even number. And there's a rule that says that any number that is an even number or it ends in an even number is divisible by 2. So, since 2 can divide 2, 2 will divide this 2 to give us 1. Remember to put your short horizontal line that separates the numerator from the denominator. And then the 2 you used in dividing the upper one, you still use it and divide the lower number. 2 divide 4 to give you 2. So that means that 2 to 4th or 2 over 4 is the same as 1 over 2, or is the same as half. Now let's look at the second number. This is 3 out of 6. Again, we know that 3 is a number that can divide 6, so we're going to divide the two numbers by the one number that we know can divide through them. So 3 divide 3, you have 1. 3 divide 6, you have your 2. Okay? So that means that 3 over 6 is an equivalent of half. Now let's look at 8 and 4. If you want to start, you can use 2 or you can use 4. That's if you know your division very well or your multiplication very well. Remember, when you are doing division, you make great use of your multiplication knowledge, multiplication facts. Okay? You really make use of it. So if you know that 2 times 4 gives you 8, you just know that 4 is going to divide through 8. But let's assume you don't know. At least you know that 2 can divide any even number. So let's use 2. 2 divides 4. It gives us 2, right? It gives us 2. And then 2 divides 8. It gives us 4. So looking at those two numbers, you know that something can still divide. Okay, we can still divide further. So let's look at it. 2 is an even number, 4 is an even number. So 2 can go again. 2 divides 2, it gives 1. 2 divides 4, it gives 2. So again, we see that 8 out of 4 or 4 out of 8, that is 4/8, is equivalent to half. So the last one we're looking at here is 5 out of 10. 5 out of 10. Using again the rules of divisibility, we know that any number that ends in 5 or 0 is divisible by 5. That is, any number that ends in 5 or 0 can be divided by 5 without a remainder. So definitely 5 we know can divide itself without a remainder. And then since 10 ends in 0, we know that 5 can also divide 10 without a remainder. So let's use 5. 5 divides 5, that's 1. 5 divides 10, that is 2. So again, we see that 5 out of 10 is an equivalent fraction of 1 over 2, that is half. So the next aspect we're going to look into now in fraction is comparing unlike fractions. Comparing unlike fractions. What are unlike fractions? Unlike fractions are those fractions that do not have the same denominator. You remember we looked at like fractions last week, okay? And like fractions are those fractions that have the same denominators. We even went ahead to do addition and subtraction of like fractions, which turned out to be very easy, okay? So, but this time around, we'll be looking at unlike fractions. First, we're going to do the comparing and the ordering. Comparing and ordering unlike fractions before we go on to do addition and the subtraction. But the addition and subtraction will be coming up in another lesson. Okay, we'll be covering that in another lesson. So today we just focus on the comparing and ordering of unlike fractions. So here we have 2 over 3. If you look at the two of them, this 1 out of 4, 1/4 to 1/3. If you look at the two of them, you find that they don't have the same denominator. So these two fractions are unlike fractions. The next example here is 3/7 and 2/5. If you look at their denominators, you find out that they are not the same number. So that means these two fractions are unlike fractions. Okay? Now, remember when we did like fractions the other time, when we were comparing, we gave example like if you have 1/3 and maybe 2/3. To check which of them is bigger, you simply look at their numerators. So whichever has a bigger numerator is the bigger fraction. So for these two, if you're using a symbol of comparison, this is smaller than 2/3. Imagine you have a pizza that is cut into 3 parts, equal parts. One person picks 1 part and this person picks 2 parts. Who picks the greater part is the one that has 2 out of the 3. So you see, it's quite easy when you're comparing like fractions. It's very easy to tell which is bigger and which is smaller. And you do that by simply looking at the numerators. The bigger the numerator, the bigger the fraction. The smaller the numerator, the smaller that fraction is. Okay, so it's as simple as that. But when we come to unlike fraction, it's not so simple because the denominators are not the same. The denominators are not the same. So what do we do? In order to be able to compare unlike fractions, you have to first be able to make the denominators look alike. You have to look for a way to make these two denominators to look alike. Change their denominators to something that look the same, like the way you have in like fractions. So by the time you're able to do that, you can now check which of the two fractions is bigger than the other or which one is smaller than the other. We're going to look at how to do that quickly, and then we do our ordering as well. So we're going to look at the first two fractions we have here, 2/3 and 1/4, okay, or 1/4. So we're going to compare these two numbers, but like we mentioned earlier, they have different denominators, so that makes it quite difficult, or let me not use the word difficult, that makes it a little bit challenging for us, okay? But there's just one thing we need to do, and then we can go ahead and compare them. That is, we need to make these denominators look alike, or we need to look for something they both can divide. What do they have in common? We need to look for a number that the two of them can divide into without remainder, and the smallest of those numbers is what we're going to use. So by the time we bring that in, the two denominators will look alike. The lowest common multiple of 3 and 4 is what we're going to do. Remember, we did LCM in our previous lesson. Lowest common multiple. That means the lowest number that 4 and 3 can divide without a remainder. Now you see why it's important, because these things are built upon, like you're building, one block upon the other, just like that, step by step. All these were taught already, so that now that we are doing this, we'll be able to use the knowledge of LCM to solve this problem. So now we are going to check what is the lowest common multiple of 3 and 4. Remember, there's a method we used. I have a shortcut I use, but it might not always give me the lowest common multiple. It mustn't always be that to give the correct answer, but it's advisable you use that, okay? Some people can just do 3 times 4, it will give you 12, and you go ahead and use 12. But let's use the LCM method we learned about. So here, you have your 3, and you have your 4, right? So we start always from the lowest prime factor, which is 2. 2 cannot divide 3, so 3 will be repeated. 2 can divide 4, and that gives us 2. Now 2 will go again. It can't divide 3, you repeat 3 again. It can divide 2, it gives 1. 2 divide 2 is 1. So what's remaining? 3. So 3 divides 3, it gives 1, it gives 1. Now what is your LCM? Your LCM is equal to 2 times 3 times 4. Sorry, 2 times 2 times 4. 2 times 2 times 3, and that is 12. Okay, now you see that without going through this process, you could have just said 3 times 4, and that would have given you 12, right, as your new denominator. Remember, the LCM we worked out here is going to become the new denominator for the two numbers. Okay, so how do we arrive now at the top numbers? Now this is what you're going to do. Okay, let me not put this here first. So you're going to, I hope that we have enough space. Okay, so let's manage this space. So this is our lowest common multiple, the LCM. So now to get the new numerators, because the new denominator is definitely going to affect the numerators. Here is what we now do. You divide this LCM by the denominator. The answer you get multiplied by the numerator. So let's start with the first one. So 12 divided by 3, that is 4. 4 times 2, that's 8. So the first fraction now has 8 as the numerator and the denominator is 12. Now let's do the second one. So the same thing you did here, what you did here is what you're going to do for the second number. Also divide the LCM by 4. 12 divided by 4 is 3. 3 times 1 is 3, so 3 over 12. Remember we said the two of them will now assume this LCM will become the new denominator, the common denominator for the two fractions. Why does this have to be? We need the two denominators to be equal so that we'll be able to compare the fractions. Remember when we were doing fractions, equivalent fractions and all of that, we always say that the base has to be equal so that you can easily compare the parts within it. So it's the same thing that applies here. You find out that if the denominators are not the same, there is no ground for comparison. You won't be able to compare the two and say this is bigger than this. But once the base, the denominators are the same, then you can easily compare the fractions. So here, first we looked for the LCM of the two denominators. We got 12. Please pay attention, okay? We look for the LCM of the two numbers 3 and 4. And we got 12. You remember from my LCM lesson, we did LCM and HCF. You can refer back to that video, okay? This is how we look for LCM. Write out the numbers. You start dividing until you divide everything out. Nothing is left to divide, okay? Then you now multiply the prime factors. The prime factors are 2 times 2 times 3, and that gives us 12. Now, I pointed it out to us that without going through this process, we could have also said 3 times 4 gives us 12. But it is not in all cases that you'll be lucky enough to arrive at the same answer if you skip this LCM process. You may multiply and get a bigger number than 12. I'm just using 12 now. A bigger number than what you would have obtained ordinarily if you used the LCM method. Okay, but the truth is, if you know how to still reduce your answer to the lowest common term or the simplest term, you will still arrive at the correct answer. Okay, so now we got our LCM, which has become the new common denominator. The new common denominator. So what do? This 12, which we got from here, we will divide it by 3. And the answer will multiply by the numerator. Divide the new denominator by the old denominator. The answer you get multiplied by the numerator. So when we did that, 12 divided by 3 is 4. 4 times 2 gave us 8. It's now 8 out of 12. This has become the new denominator. We do the same to the second fraction. 12 divided by 4 is 3. 3 times 1 is 3 over the new denominator, which is 12. Now looking at these two, we can easily do a comparison. Remember we said when you're comparing like terms, that is fractions that have the same denominator, you simply look at their numerators, the numbers at the top, to see which is bigger or which is smaller. In this case, we know that 8 is bigger than 3. And we said when we're looking at like terms that the bigger the numerator, the bigger the fraction. So if we agree that 8 is bigger than 3, then that means that 8 out of 12 is bigger than 3 out of 12. Now, this is not what we're going to write as our answer, because when we started off, we didn't start off with 8 over 12 as fraction or 3 over 12. No. So what do we now do? This 8 over 12 is the fraction representing 2 out of 3. That means 2 out of 3 is greater than 1 out of 4, because 3 over 12 is the fraction representing 1 over 4. So this is how you do your comparison. Right? This is your comparison. Okay, let's look at the second example. So let's look at 3/7 and 2/5. Again, we see that the denominators are different. That means we can't just easily compare. So what do? We try as much as possible to give them a common denominator. We try to give them a denominator that is the same, so that there will be room for comparison. We'll be able to compare them using their numerators. So like we did in the first example, we are going to find the lowest common multiple for 5 and 7. That is the smallest number that 5 and 7 can divide without a remainder. So let's start just like we did the other one. So look at these two numbers. Is there any number among them 2 can divide? Because 2 is the smallest prime number that we always use for division. Okay, so that's where we always start from. But if you find that you can't get a number that 2 can divide, you will try the next number, which is 3. So you keep trying until you're able to get what you're looking for. So looking at 5 and 7, these are odd numbers. And we know that 2 cannot divide any odd number without a remainder, so we can't use 2. The next prime number is, or prime factor we can check, is 3. After 2, you have 3. 3 can divide 5 without a remainder, and 3 can divide 7. So after 3, the next prime factor or number is 5. And we have 5 here as a number, so which means we can use 5. Can use 5 to divide, at least to divide the 5. So 5 divides 5, it gives us 1. 5 can't divide 7, so we repeat 7. Now we have just two numbers, 1 and 7. We know 1 is already out of the question. So the only number left is 7. And we know that 7 also is a prime number. It's a prime number, and that means that only 1 and itself can divide it without a remainder. There's no number that can divide 7 without a remainder, apart from 7 and 1, apart from itself and 1. So the next number we can use here is 7. So 7 divides 7. We have 1 here, we have 1 here. So everything is out. Everything is out. Now how do we get our LCM? We get our LCM by simply multiplying the prime factors. So 5 times 7, that gives us 35. 5 times 7 is 35. That means our new denominator is 35. That's our new denominator. So now let's go back to our fraction. Okay, so what do we do? Okay, let me just write it out this time. Don't want to be. So we have 2 out of 5, right? Now we have 35. That's the new denominator. So now to make these two fractions become like fractions, we will divide the new denominator by the old denominator and multiply our answer by the numerator. So how do we do that? Maybe I should just write it out in this particular one. So we are going to do 35 divided by 7, whatever answer you get, times 3. That is for the first number. And for the second number, it will be 35 divided by 5, whatever answer you get, times 2. Okay? I'm just trying to write this out so that at least once you see this, you'll see the process involved in this part. Once you have gotten your LCM, how you will now go on to convert the fraction to like terms in order to be able to compare. Okay, so 37 divided by 5 is 5. 5 times 3 over 35. And the other one is 35 divided by 5 is 7. 7 times 2 over 35. Now we can see that the two fractions are looking as like fraction because they both have the same denominator now. They both have the same denominator. So what do we do? 5 times 3 is what? 15 over 35. And 7 times 2 is 14 over 35. And using what we have always known of like terms, we say that the bigger the numerator, the bigger the fraction. And we know 15 is bigger than 14, so that means 15 over 35 is bigger than 14 over 35. And okay, one more step. We can't stop here because these are not the fractions we are comparing. The fractions we are comparing are 3/7 and 2/5. Okay, we just use their own equivalent to represent them in like terms so that we'll be able to compare. Now we have gotten our answer. We know that 15 over 35 is actually representing 3 out of 7. That means 3 over 7 is bigger than 2 over 5, which is represented by 14 over 35. So this is our answer. Okay, so here I'm just going to quickly state that when you are ordering, because before you order, you must compare. If you are going to order fractions, you're giving fractions, unlike fractions to order, this is the step you follow. Okay, this is our second example, okay? This is the step you follow. So first you look for the LCM. All you're seeking to do is to try and make them have the same denominator. Once they have the same denominator, it becomes easy for you to compare them. So how do you make them have the same denominator? Like the first example we looked at, you see that you could have also easily gotten the denominator by just saying 7 times 5, which would have given you 35, the same answer. But like I said, that multiplying of the two denominators doesn't always give you the lowest common multiple, which we solve through this process. But again, even if you don't get the lowest common multiple, multiplying the two denominators, whatever number it gives you, once you are able to still reduce it to the lowest term, you will still get your final answer. It will still give you the correct answer, okay? We do the lowest common multiple because it will reduce the bigness of the numbers we are going to come up with. We go for the lowest common multiple. Otherwise, it's still a common multiple you will get when you multiply the two denominators together. So it's your choice. You can just go that way and forget about the LCM process. Just do multiply the two denominators together, you get your new denominator. And once you get your new denominator, what do? Divide that new denominator by the old one and multiply the answer by the numerator. You do that for the first fraction, you do it also for the second fraction. At the end of the day, you end up with two different fractions that have the same denominator. 15 over 35, 14 over, you can see they look different from this, but the truth is they are actually equivalent fractions of these fractions you see there. The equivalent fractions. So 15 over 35 is representing 3 over 7, and 14 over 35 is representing 2 over 7. So here we can easily tell which is larger. 15 is larger than 14. So that means the fraction 3 over 7, which is represented by this, is bigger than 2 over 5, which is represented by the other one. So like I mentioned in comparing, once you're able to get this done, you now know how to compare your, how to order your fractions. So if you're ordering this one, for instance, it will look something like 2 over 5 is less than 3 over 7. And if there are other fractions as well, you line them up. You can either use this sign. I've mentioned it before. If there's another one that is larger than this, you write it. You write the x over y. Just like that, you continue. I've told you this is one way of ordering. Another way is by using your comma. It's by using your comma. So you can write 2 out of 2 over 5, comma, 3 over 7, comma, x over y. And it goes on like that. So this is how you do your ordering without knowing, without comparing to know the values of the fractions. There's no way you can know that. But once you're able to compare them, you know their values, ordering is as simple as it gets. So here is where we're going to call it a day. Thank you so much for being a part of this lesson. I know it's not a straightforward thing, but with practice and then you going over this video again until you get a hang of it, will really go a long way in helping you to become a master of this concept. So I encourage you to go over this video again, jot down points, solve problems, and you're just going to find out that it's as easy as ABC. Trust me. Okay, it's good being here with you. Really nice. I hope to see you again next week. Until then, stay blessed and stay safe.